Okay, we're going to do number 5. A problem like number 5. Now, this one I asked for the pressure on a side, and it could have been any of the sides. And I asked for pressure on the bottom and the force on the sides. Now, if this were in feet, I'd be using the weight density of water in feet. And that's 62.4 pounds per cubic foot. But if I'm in the metric system, I do the 9,800, 1,000 times 9.8 newtons per meter cubed. So those are the weight densities I want to get involved with here. Now, if I want to know the pressure at the bottom, the pressure is a very simple thing. If you go down 1 meter, the pressure is 9,800 newtons per square meter. I just multiply by 1 meter. Cancels one of them, and the pressure is 9,800 per meter squared. If I go down 2 meters, it's 2 times that. If I go down 3 meters, it'd be 3 times that. So if I ask for the pressure at the bottom of this, it's simply the weight density times how deep the water is, which creates 9,800 times 3 newtons per meter squared. And pressure is force on a square area. And 3 times 9 is 27, and then 32, so that's 3, try to do this in my head, and I'll probably make a mistake, so I want to do it right. 9,800 times 3. 29,400. Yep, I would have made a mistake. Newtons per meter squared. If this was 3 feet and 1 foot and 2 feet, I'd be taking 3 times that, and I would get pounds per square foot. That's it for the pressure at the bottom. The pressure at 2 feet down, I'd be taking 2 times this if I'm in the metric system, and 2 times that if it was in feet and I'm doing the English system. So it's just the depth times it. And that's why when we want to find the push on the side, the pressure is pushing on an area. Pressure is a force on an area. So if I want to find the force on the side, I will need to figure out how much pressure is on it, and that varies as we go down. So we want to look at a little rectangular slice of the side. So I'm going to slice the side. And that would be a rectangle. And I don't care what you call this. It could be dx or dy. I'll just call it dx. And the pressure on there is dependent on the depth. So all I need to know is how far down that is in the water. So I'll put the origin there. And so the pressure on this strip will be x times the correct weight density. And this is in meters, so it would be times this one. So the force on there will be the pressure, 9,800 times x. That's how much pressure there is at that depth. And that's per meter squared. So then I have to multiply by the amount of square meters that is. Well, its height, this rectangle, is a height of... So much for using my phone to record with. Keeps shutting down on me. I was here and I was just starting this. So this slice is a rectangle, dx, and it's 2 meters long. So I got to find the area of this. The pressure there is, like I said, is 9800, the weight density, times how far down it is in the water. So it's 9800 times x. That's the pressure at that depth. And that pressure is pushing on this rectangle. This rectangle that's 2 meters by dx meters, so I have to take it times 2 meters times dx meters. So I've got the weight density times the depth times the area, and that will be these 3 meters cubed will cancel meters cubed and leave me with newtons. So if I take 2 times the 9800, that comes out. X is going to go from the right at the top all the way down. We're going to add up all the rectangles all the way down here. So it's going to be x is going to be left in, the dx, and 2 times that comes out. X is going to go from 0 to 3. Integrating x, I get x squared over 2 from 0 to 3 times the 19,600. I put in the 3 and I get 9 halves. Put in the 0, I get 0. This times this is that. And that would be newtons. Once again, that's newtons because the weight density is 9,800 newtons per meter cubed, and we multiplied by meters and by meters and by meters. Meters, and the depth. That's it. That's how simple that one is. Now, if I were trying to do this side, the pressure on the front side here, then the rectangle would be 1 meter, dx meters, and the pressure would still be x times 9800. So it'd be 980 times x, that's the pressure at that depth, times 1 wide times dx. So it just changed, and that would be a 1, and it would be half as much. It's half as much area as this is. And so it would be this force, which is in newtons. That would be the force on that. I think I said pressure, but I should say force. Okay, that finishes 5.